Welcome back. In this class we're going to talk about esters. Of all of the different functional groups, esters are considered the most difficult to draw and name, and we're going to build on everything that we've covered from the other functional groups to be able to draw and name the esters. Esters are very common in question 8 and they usually come up for a minimum of 6 marks. If you can draw the ester, you get a full 6 marks because the structure is more difficult than a traditional carboxylic acid or alcohol. So more marks are on offer for being able to draw the ester properly. If you can then name the ester after that, you get an additional 3 marks. On top of that, if you can also draw and name ester isomers and carboxylic acid isomers of the ester, then you're onto a winner with an ester question because that is the most difficult question that the examiner can ask you. Right, so let's have a look at the list of items that you need to be able to do for esters. Number 1, you need to be able to identify and circle the functional group, same as the other functional groups that we have seen. Number 2, you need to be able to give the UPAC name of the ester. Now it's a little bit more complicated than the previous ones because it has 2 parts to the name of the ester. Number 3, you need to be able to identify the alcohol and the carboxylic acid that formed a particular ester. How this will come up is the examiner will either give you the ester itself, either the name of it or the structure, and they'll ask you what alcohol and what carboxylic acid could be used to form this ester. Number 4, you need to be able to draw the structure of different esters based on their formulas or their names. Number 5, you need to be able to draw and name ester isomers. And then number 6, identify that carboxylic acids and esters are isomers of each other. Now that is something that I would definitely know going into the 2025 exam this year, because that type of a question, knowing that different families are isomers of each other, it wasn't touched upon at all in last year's question 8. So it's kind of sticking out that this year it could come up in question 8. So it's something that I would definitely focus on in my revision. Now, before we start looking at esters, structures, etc., I want you to pause the video and I want you to go off and get 2 different coloured pens. So it's either on your desk, in your school bag or wherever else. Because when it comes to drawing and naming esters, I'm going to show you the part of the molecule that comes from the alcohol and the part of the molecule that comes from the carboxylic acid. And we're going to do it in 2 different colours, because if you do it that way, it makes the naming of the ester an awful lot easier. Right, so let's start off with some key information about esters. Esters have the functional group COO, like that, where you have a C double bond O and the carbonyl carbon is attached to another oxygen. But it's in the middle of the compound, it's not at the end of the compound. So your C double bond O is in the middle like that, and so is the oxygen. Now that oxygen cannot be attached to a hydrogen. If this was a carboxylic acid, your carboxylic acid would look like this, where the oxygen, the single bonded oxygen, is bonded to a hydrogen. So they are 2 completely different functional groups. The ester functional group is this bit here, and the carboxylic acid functional group in the one on the bottom is this bit here. Okay. Now, for the ester, when you are naming the esters, esters are tricky because they come from a combination of the name of the alcohol and a combination of the carboxylic acid that was used to form the ester. And we'll go through that in just a second, but it has 2 parts. The first part will be IL and the second part will be OH. This ester on the right hand side is methyl ethanoate. So how do I know it's an ester? Because it ends in IL, OH, and that's a dead giveaway that it's an ester. Now, the next thing is a common question on the exam is to describe the smell of an ester. Esters smell very sweet and are commonly found in fruity fragrances. So if the examiner asks you what functional group is responsible for fruity smells, the answer is an ester. Now another one. As for the properties of your esters, because they have a C double bond O in their structure and a carbon single bonded to an oxygen like that, and then to another carbon, this is a polar molecule. You've got delta plus, delta minus, delta minus, delta plus, etc. So it is polar covalent. Now, even though it's polar covalent, see if you can figure out what the intermolecular force between ester molecules is. So, 50-50 chance of getting it right. It's either hydrogen bonding or dipole-dipole. Go for hydrogen bonding first. Does the ester have an oxygen, nitrogen, or fluorine? Yes, there's an oxygen there. Is there a hydrogen attached to that oxygen? No. So esters have permanent dipole-dipole intermolecular forces. Esters will have a higher boiling point than the corresponding alkanes, but a lower boiling point than the alcohols or carboxylic acids, and that's important. Now, solubility. In terms of their solubility, because your ester is polar, would it be soluble in water? Yes, it would. So esters are polar covalent. They can form hydrogen bonds with water. If I was to draw a hydrogen beside this molecule up here on the right, or not hydrogen, water. I'm going to move it down so you can see. Water is polar covalent. You have delta minus, delta plus, delta minus, delta plus, delta minus, delta plus. When you have opposite dipoles near each other, there is a force of attraction between them, and that is a hydrogen bond. Esters cannot hydrogen bond with themselves, but they can hydrogen bond with water, because water has an oxygen, and there's a hydrogen attached to that oxygen, meaning the dipole is bigger. So the intermolecular force is stronger. So from that, we know that esters are soluble in water because they can hydrogen bond with water, but is specifically the short chain esters. Now, like what we learned off with the alcohols and carboxylic acids and aldehydes and ketones, as the chain length increases, the solubility decreases. As the chain length increases, the non-polar section is getting bigger. That counteracts or overcomes the solubility provided by the polar part. So long chain esters with lots of carbon atoms, they are not soluble in water. Now next, if I was to compare boiling points at this stage between the families that we saw. Now it's not going to ask you to compare the boiling point of aldehydes and an ester. There's going to be something very distinct and different about what you are comparing. So from all of the families that you would be comparing, alkanes are always going to have the lowest boiling points, because the only intermolecular forces they have are van der Waals because they are non-polar covalent. Now next up, you're going to have something that only experiences dipole-dipole or van der Waals. So they're polar, but they can't hydrogen bond. These would be your aldehydes, your ketones, and your esters. They all have dipole-dipole. Now my next one would be alcohols, because they can form hydrogen bonding, intermolecular forces, and the ones that will always have the highest boiling points are the carboxylic acids, because they have two completely separate polar parts. They can form two hydrogen bonding intermolecular forces. Okay, and more energy is needed to overcome two hydrogen bonds than one. So the carboxylic acids will always have the highest boiling points, and alkanes will always have the lowest. Now, that's really important that you can compare the boiling points of those in terms of their intermolecular forces and the strength of those forces and the energy needed to overcome them. Right, let's have a talk about forming esters. Now, in order for an ester to be formed, you have to start with two molecules. And it's formed when an alcohol reacts with a carboxylic acid. So we have an alcohol plus a carboxylic acid. And when the two of those combine, we form two products. We have an ester plus water. Now, any reaction between an alcohol and a carboxylic acid that forms an ester, the name of this type of reaction is called esterification. And we'll see esterification a little bit later when we cover addition reactions in organic synthesis. So esterification, that's the name of the reaction when you form an ester. And the reverse will be hydrolysis, but we'll see that later. Now, it's really important with this that you recognize that the second product formed is water, because quite often you are asked to draw the products of this reaction, and 9 times out of 10 students forget to draw the water. So don't forget that. Now for this, I want to have 2 different coloured pens as we're going through this, because I'm going to show you where the alcohol attaches onto the carboxylic acid. Now in your notes at the top of page 331, there's a definition box for a condensation reaction. Condensation reaction is a chemical reaction in which 2 molecules combine, so in this case it's our alcohol plus our carboxylic acid, to form a larger molecule, the ester. And water is lost or kicked off of the molecule. So you are, for condensation is water. You are producing water. Okay. Now, when you are naming your ester, the alcohol part, that forms the first part of the ester's name. So if your alcohol was methanol, the ester that will form will be methyl something. If the alcohol was ethanol, then the ester will start with ethyl. If it was propanol, it will be propyl. If it was butanol, it will be butyl. So the alcohol part of the reagents needed to form the ester, they will form the part that ends in YL. So take off the anol part of the alcohol and put YL there instead. So methanol becomes methyl, ethanol becomes ethyl, etc. For the carboxylic acid, this will form the last part of the ester's name, the second part. For the carboxylic acid, if you have methanoic acid, so methanoic acid, when you name the ester, that will be methyl, methan. Now here, watch what I'm doing. I'm taking the oic acid off, the part of it that tells me it's a carboxylic acid. And now the end of the name will be methan O8. So you replace it with the O8 part of the name of the ester. If it is ethanoic acid, then the ester will end with ethan O8. If it was propanoic acid, then it will end with propan O8. Butanoic acid will end with butan O8. Now, I'm spending a little bit longer going through the naming here because it is important and it is tricky to name esters. Right, so that's the naming of it. Now, I'm actually going to draw the structure of an ester for you. So if I get rid of my names here, I'm going to draw an ester as it's shown in your notes, from the alcohol and the carboxylic acid that was used to form it. Now, if I started off with, I'm going to do blue for the alcohol, methanol. So methanol has one carbon and my alcohol functional group. And if I go for ethanoic acid, which has two carbons. Now, before I show you how to draw this ester, we're going to name it. So I know I'm starting with methanol and ethanoic acid. The name of this ester, take the alcohol part first. So methanol, the first part of the ester's name will be methyl, and then the second part will be ethanoate when the two of those molecules combine. Now, to show how the ester forms, I'm just going to swipe to the right hand side just to give myself a little bit more room. And I'm just going to redraw my alcohol. Now, pay attention to this bit because a lot of people can't see how the ester forms and they get confused with where it is. Okay, so the ester here. Now, on the alcohol, the carbon that's attached to the OH in the alcohol. So in methanol, it's that carbon. That is going to form a bond, the oxygen in the alcohol, so the single bond to the oxygen. That is going to form a bond with the carbon in the carbonyl group of the carboxylic acid. Try and say that 10 times fast. Now, how that happens is, so that oxygen has to form a bond to the carbonyl carbon. Now, oxygen as it stands on the methanol has two bonds and it can't have any more. So in order for the oxygen to form a bond with that carbonyl carbon, it has to kick off this hydrogen atom. Same for the carbon in the carboxylic acid. That carbon already has 4 bonds. It can't have 5. So when we form a bond between the oxygen from the alcohol and the carbonyl carbon like that, that carbon now has 5 bonds. Can't have it. So what we do is we break the bond between the carbon and the OH and it kicks off the OH group. Now, this molecule is kicking off an OH and the alcohol lost a hydrogen. So those two combine together and that's where the water comes from. Your alcohol part will lose a hydrogen and the carboxylic acid part will lose an OH. And that is the structure of the ester. Now, when you're naming the ester, your alcohol part, the bit with the single bond to the oxygen, this is the bit that came from the alcohol. So looking at it, this is the alcohol part that has 1 carbon attached to it. It's methyl. And then if I look at the other side, the bit with the C double bond O, that is the bit that came from the carboxylic acid. So then if I highlight all of this bit here, we know this part came from the carboxylic acid and it has 2 carbons in it. So it would be ethanoate. And that's what the structure of methyl ethanoate looks like. Okay. So if I was drawing it from scratch and I was drawing methyl ethanoate, I would actually draw from the ester group out. So for the methyl part, I have the oxygen and it's meth, so I draw in 1 carbon with the hydrogens. And then for the carboxylic acid, I have 1 carbon shown and it's ethanoate, so I have to draw 1 more carbon to give me a total of 2. And don't forget that your second product is water, or H2O. That's something that's going to cost a lot of people marks if it comes up this year. So don't forget the water. Now, I'm going to do this for a few different esters because students really struggle with this, and they absolutely do, and it is understandable. But I'm going to try and keep the colour scheme the same, where I'm going to put the alcohol in blue and the carboxylic acid in pink. Now, I don't care which one you put as pink or green or purple or whatever colour you want. The different colours are to show where the bond is formed and what part of the molecule came from the alcohol and what part of the molecule came from the carboxylic acid. So if I start with this alcohol, Okay, this alcohol has 2 carbon atoms, so it's ethanol. And I want this carboxylic acid. This is propanoic acid. Okay, now what attaches to what? The oxygen from the alcohol, that forms a bond to the carbonyl carbon. So that's where the bond is going to form. If I was redrawing this, I'm going to start with the carbonyl carbon and then the single bond to the oxygen from the alcohol. And then you work your way out. Continue the rest of the alcohol. So I've drawn in that oxygen. I have 2 more carbons to fill in. Then, for the carboxylic acid part, I have the carbonyl group shown, and I have 2 more carbons to fill in as well, with their hydrogens. Now, there's my ester. Don't forget your second product is water. Now, where did the water come from? Your alcohol loses that hydrogen, and your carboxylic acid loses that OH group, and they combine together to give you water. Now, name this ester. So start from the name of the alcohol. You have ethanol, that means this will be ethyl. Then name the carboxylic acid part. Propanoic acid becomes propan O8. Now your marks in the exam. You get 6 marks for the structure of the ester and 3 marks for being able to name it. And we're going to do quite a bit of practice with drawing esters in just a minute. But I am going to show you something now that a lot of students get in the habit of reading it as the alcohol from the left and the carboxylic acid from the right. It depends on how the structure is shown. If I was to draw this molecule here, and asked you to name this. Now, what I would do here is take 2 different coloured highlighters and we're going to highlight the part that came from the alcohol and the part that came from the carboxylic acid. Now, to identify the bit that came from the alcohol, you're looking for the single bond to the oxygen and what is after it. So that would be this bit here, because that's where the single bond to the oxygen is. Therefore, the bit that came from the carboxylic acid is this bit here with your C double bond O in it. Now, naming this ester, because your alcohol part has 1 carbon, the name of the ester will be methyl, and your carboxylic acid part has 1, 2. That would be methyl ethan O8. 2 guesses for what most people would name that. Most people would name that as ethyl methanoate, and that's not correct. If I was to draw ethyl methanoate, that would be from ethanol, where your oxygen that's single bonded to your carbonyl group would have 2 carbons attached to it, like that. And then you just have a hydrogen there. And this ester, circle the bit that came from the alcohol. It's this bit here with the single bond to the oxygen. That would be ethyl. And the bit that came from the carboxylic acid is the bit with the C double bond O. It has 1 carbon, so it will be ethyl methanoate. Those 2 molecules, they are structural isomers. They have the same number of carbons, hydrogens, and oxygens, but they are arranged differently. They will also be formed from different carboxylic acids and different alcohols. From methyl ethanoate, the alcohol will be methanol, and the carboxylic acid is ethanoic acid. Whereas the diagram at the bottom, that would be formed from ethanol, which is a different alcohol, and methanoic acid, which is a different carboxylic acid. Okay? Now, that's important. Remember, you have molecular rotation. So I would actually get in the habit of being able to split the ester up into the alcohol part and the carboxylic acid part, because that's going to make your life easier in the exam, because the examiner can rotate the molecule if they give you the structure, and it will lead to less confusion when it's written like that. One last thing, when you're writing when you're given the formula of the ester, it can be a bit of an awkward one because it's actually drawn with the carboxylic acid side first. So if I wrote the formula CH3, CH2, COOCH3. This is an ester functional group where you see the COO in the middle of the chain. That's an ester. How do I know it's not a carboxylic acid? Because the carboxylic acid would be COOH. Here we have another carbon instead of that hydrogen, so it's in the middle of the chain. Carboxylic acids can't be in the middle, they have to be at the end. Now, if I was drawing this one out, you start with your CH3, which is then bonded to two hydrogens. Now, COO, when it's written like that, that's C double bond O, and then the single bond to the oxygen, which is then bonded to a CH3. If I was naming this ester, highlight the bit that came from the alcohol. It's this bit here with the single bond to the oxygen. This is methyl. Then we highlight the part that came from the carboxylic acid, which is this bit here with the COO. And it has 1, 2, 3 carbons. So it's methyl propanoate. Okay. Now, the naming of esters is quite tricky, so I don't expect you to get it the first time you see it. So we're going to go through the practice questions and a worked example that we have in our notes, just to get us used to these types of questions. Now, the worked example. Draw and name the ester formed when ethanol, so my alcohol is ethanol, reacts with propanoic acid. Now, honestly, at this stage, if you're a little bit hesitant when it comes to esters, draw the alcohol and the carboxylic acid. You're far less likely to start dropping carbon atoms if you draw both of those starting compounds first. Ethanol has 2 carbons with an OH group. Like that, and my propanoic acid, so that's my carboxylic acid, and propan is 3 carbons that we have to draw in. Now, to form your ester, the oxygen from the alcohol is going to form a bond with the carbonyl carbon. So when you're drawing the ester, start from there, start from the ester bond. You've your C double bond O from the carboxylic acid to the single bond to the oxygen. Now I have to fill in the rest of that alcohol. That oxygen is bonded to 2 other carbons like that. And then fill out the rest from the carboxylic acid side. Now we've drawn the C double bond O, but I still have this part to fill in. So we have a CH2 and a CH3 on the end. Now, that's my ester. So I have drawn the ester 6 marks. 6 marks for the drawing of it. Now we have to name it. And this is why I want it done in 2 different coloured pens, so it sticks out at you which part is the alcohol part. It's this bit here. So it will be ethyl from ethanol, and the last part of it will be propanoate from the propanoic acid for 3 marks. Now, they do take a little bit of practice just to get your head around, but if you're struggling with esters, I strongly recommend you draw the alcohol and the carboxylic acid first and then stick them together. Right, so let's do some of the practice questions. So A in your notes on page 332. Draw and name the ester and the other product formed from the reaction of each of the following alcohols and carboxylic acids via a condensation or esterification reaction. We're going to react methanol with ethanoic acid. Now I'm just going to move over to here because I don't have a whole lot of room because I put the question there as well. So I have methanol, which is 1 carbon with an OH attached. That's my methanol. And my carboxylic acid is ethanoic acid, which is 2 carbons and a carboxylic acid group. Like that. Now, to form my bond, the single bond in the oxygen in the alcohol has to stick onto the carbonyl carbon. So I'm going to start my ester from there. I draw my C double bond O to the oxygen from the alcohol, and then we work outwards. That oxygen in the alcohol is also attached to this bit here. So I need to fill in that CH3. Then for the carboxylic acid part, we've already filled in the carbonyl group, but it still has this bit here that we haven't filled in yet. Okay. That's the ester, 6 marks, and my other product is H2O. Now, name the ester. Comes from the alcohol first. Methanol will form methyl, and the carboxylic acid is ethanoic, so that will be ethan O8. And your other one is water. Okay. Now that's your first one with methanol and ethanoic acid. My next one is methanol with propanoic acid. So again, I'm going to draw out methanol and propanoic acid. Now propan is C3. Okay. Right. The oxygen from the alcohol attaches onto the carbon in the carbonyl group of the carboxylic acid. So when we're drawing the ester, we do the C double bond O, then we single bond to the oxygen from the alcohol, and then we figure out what else we have to draw in. So that oxygen there is this oxygen from the ester. So now we still have to fill in the rest of that molecule. That oxygen is attached to CH3. And then from the carboxylic acid part, we haven't filled in this bit here yet because we have the C double bond O, so just be careful that you don't put that in twice. There we go. So there's my ester. And my second product is water. Like that. Now naming the ester, go for the alcohol part first. Methanol becomes methyl. And propanoic acid becomes propan O8. Like that. Next, let's try part C. Now part C is a little bit different because it's bigger. So this one we have propanol. Propanol is 1, 2, 3 carbons with an OH. Now don't get yourselves in a twist about, oh, what if it's propan2ol? The examiner's not going to give you something rotten like that. It's going to be the primary alcohol. Esters are difficult enough as it is without bringing that into it. Okay. Then the oxygen from the alcohol attaches onto the carbonyl carbon, so we form a bond between the two of them. We have C double bond O from the carboxylic acid and the oxygen from the alcohol. And then we build outwards. Now from the alcohol side, we need to include all of this bit here. So 1, 2, 3. And don't forget to fill in all of your hydrogens and all of your bonds. Like that. And then for the carboxylic acid part, we haven't filled in this bit here yet. So we have to put in a CH3. Plus, we have water on that side. Now, the name of the ester. Because you're starting with propanol, the ester will start with propyl, and the last part, ethanoic acid, this will become ethanoate, like that. So I've got propyl ethanoate for 3 marks, and the structure for 6 marks. Now, the last practice question that we're going to go through for these ones is butanol and propanoic acid. Butanol is C4. And propanoic acid is C3. Now remember, every carbon has to have 4 bonds. And then we show our carboxylic acid off the side. The oxygen from the alcohol attaches onto the carbonyl carbon, and it can't attach anywhere else. It has to be the carbonyl carbon. So we draw that part first when we're drawing the ester, the C double bond O, and that is single bonded to the alcohol. Now fill in the rest of the alcohol part. I haven't filled in any of this, so I have to fill in 1, 2, 3, 4 carbons and all of their bonds and hydrogens. Then for the carboxylic acid, we need to fill in all of this bit here, which is another 2 carbon atoms. Then that's water. Now naming this ester, we have butyl, and the ending will be propan O8 from the propanoic acid. Now, I'm going to show you another common question that comes up in relation to this on the exam. And it's where they give you the ester and they ask you to identify the bonds that break to form that ester, or they will ask you to identify the alcohol and the carboxylic acid that would be needed to form the ester. So I'm just going to move over here to the side and I'm going to draw an ester. Okay, so there's my lovely ester. Now careful. Go in with our highlighters and we're going to highlight the part that came from the alcohol. So the bit that came from the alcohol is this bit here, because that's the bit with the single bond to the oxygen. And this bit here, the bit with the C double bond O, that came from the carboxylic acid. So the alcohol that's used to form this, you have from the alcohol part 1, 2 carbon atoms. Your alcohol would be ethanol. And your carboxylic acid part, you have 1, 2, 3, 4. Would be butanoic acid, if it asked you for the name of the alcohol and the carboxylic acid used to form that particular ester. Now, another question that they might give you is, on this structure, identify the bond that is formed when the ester forms. So this would be the bond between the oxygen and the carbon. It is the single bond. Be very careful. When you're identifying bonds on the exam paper, always draw out the structure and literally put an arrow to the bond that you are talking about. Don't write a sentence here, because if you were to write a sentence, a lot of students will say, oh, it's the carbon-oxygen bond. And I'll go, which one? Because there's 2. You have a double bond to the oxygen here, and you have a single bond to the oxygen there. So which is it? It's the one with the single bond. That's the one that's formed. Nothing happens to the one with the pi bond. So that is the bond that is formed. So you draw out your structure, you draw a nice arrow to it, and we put a label on it saying that is formed. Now, if I wanted to break up this ester, there is a reaction that breaks up the ester. It's called hydrolysis, and it breaks at the same point. So if I was breaking up the ester back into the alcohol and carboxylic acid, which we will see in a little bit, it actually forms a salt and the alcohol using sodium hydroxide or a base. It's still the same bond that's broken. This would be the bond that's broken during hydrolysis. Then the alcohol part reforms the alcohol. So your alcohol bit, if I was to break that apart, will reform that, which would be ethanol. And the bit that came from the carboxylic acid, it does take an oxygen back on it, but it actually takes the metal from the base. Now, don't worry about it for now. We will see it later when we're looking at the hydrolysis reaction, but it forms something called the carboxylate salt. It doesn't actually reform the carboxylic acid directly. Now, that is everything that the examiner can ask you in relation to esters. So just to recap, just very quickly, you need to be able to identify the ester functional group. So if it gives you a molecule or you draw a molecule, that is the ester functional group there. It's the C double bond O and the single bond to the oxygen. Then, on top of that, you have to be able to give the UPAC names for esters, and it comes from the name of the alcohol first, which will be the il part of the name, and the bit at the end is from the carboxylic acid. So if you have something from butanol and propanoic acid, that will be butyl from the alcohol, propanoate from the carboxylic acid. And don't forget that water is the second product during esterification. And you should also be able to identify, if you were given the ester, what was the alcohol that formed it and what was the carboxylic acid. So you're kind of working your way backwards. But start with, can you draw the ester first before you try to work your way backwards? Now, there's quite a few pages of practice questions in the notes, and I strongly recommend that you try as many of them as you can, particularly when you are asked to draw the name of an ester if it gives you the name of the ester. And these are found on page 338. So let's try one of these. Now on page 338, let's go for F. So question number F is propyl methanoate as the name of the ester. Now the propyl part, this is the bit that came from the alcohol. So I'm going to draw in the oxygen and draw that as a single bond to the carbonyl group in a minute. But if it's propyl, it had to come from propanol, which means there should be 3 carbons after the oxygen, like that. Then methanoate. This is the bit from the carboxylic acid. It comes from methanoic acid. So I draw in my C double bond O from the carboxylic acid, but because it's methane, there's only 1 carbon. So that will end in just a hydrogen, like that. So that is propyl methanoate. And I tend to draw it with the alcohol on the left and the carboxylic acid on the right, because that's how I read it when I read the question. But it's up to you how you draw it. You can draw it the other way around, rotate it, where you have the carboxylic acid on the left and then your alcohol afterwards. Those 2 molecules are exactly the same. Okay. Now, let's talk about isomers of esters. Now, isomers of esters tends to be a bit of a tricky question, and it's there kind of stuck on as a more challenging question. So if I give you the formula CH3, CH2, COO, CH3, and I asked you to draw that, apologies, start from the CH3 on the left. So I've drawn this one. Then that's attached to a CH2, like that. Then that's attached to a C double bond O and an oxygen. When it's written COO like that, it's the C double bond O is first and then the oxygen goes after it. Then I have a CH3 on the right hand side, like that. Now, if I was naming this ester isomer, this is the part that came from the alcohol. So when you're naming it, the alcohol part comes first, it's methyl. And then when you're naming the rest of it, it comes from the carboxylic acid, which is this bit here. And we have 1, 2, 3 carbons. It's propanoate. Now, that is that particular ester isomer. If they ask you for another isomer of this ester, now normally what we would do when we're drawing isomers is you take a methyl group off the end and you stick it in the middle. That's not going to fly here. Instead, the easiest thing that you can do, now watch what I'm doing, is have a look on this side where the carboxylic acid is. You have 1, 2, 3 carbon atoms. So instead of having 3 carbons on this side, I'm going to take one of the CH3s off the end here and I'm going to move it to this side to attach onto the carbon on the right hand side. So if I redraw that, I have 1, 2, C double bond O, O, carbon with a CH2 and a CH3. Okay, now this isomer is different because it's not formed from the same alcohol and the same carboxylic acid. This one, that's the part that came from the alcohol, so the name of it will be ethyl, and this is the bit that came from the carboxylic acid. So it's ethyl ethanoate. Now there is another one. If I was to take another CH3 group off the end of the bit that came from the carboxylic acid and I move it again to the other side, this is going to give me my C double bond O to oxygen and 1, 2, 3 carbons after that. And then we have a hydrogen there. Now the part of this molecule that came from the alcohol is this bit here. This would be propyl because you have 3 carbons. And the bit that came from the carboxylic acid would be this one. That would be propyl methanoate. Now the ester isomers are particularly tricky, so try and get in the habit of moving the CH3 from one side to the other and then name it again. If I had a different one, it doesn't have to be from the carboxylic acid side to the alcohol side. It can go the other way. So I'm going to show you an ester that came up a couple of years ago, and students were asked to draw another ester isomer and they freaked out. They couldn't do it. They had this one. Okay. If I was to name this ester, follow the single bond to the oxygen, this is the bit from the alcohol, and I'm flipping them on purpose to get you in the habit of looking for which part came from the alcohol and which part came from the carboxylic acid, so you don't just read it from left to right. This bit came from the alcohol, so it's ethyl, and this bit over here came from the carboxylic acid, and there is only one, so that's ethyl methanoate for 3 marks. Now, students were asked to draw an ester isomer of this, and very, very few students got this to work out. So here, what I would do is, you take that CH3 off the end of the alcohol part, and you put it on the other side. Attach it onto the C double bond O. And then that would give me this. And then we fill in our hydrogens. Now this isomer, from the alcohol part, you have 1 carbon, would be methyl. And the part from the carboxylic acid is this, would be ethanoate for 3 marks. Now, so just move the CH3 from one side to the other and instantly you're going to have another ester isomer. Now, how many can you go to? With relation to the bit that comes from the alcohol, an alcohol has to have a minimum of 1 carbon. There's no alcohol with less than 1 carbon. So here, this bit here, That is the minimum number of carbons that can be attached to that oxygen. So you can't take that CH3 off and stick it on the other side, because if you did that, you would end up with this molecule. And now that is a completely different functional group, because this bit here is a carboxylic acid. Carboxylic acids are structural isomers of esters, and we are going to look at this in a separate class because I want to dig into the isomers and be able to show you how to work them out. And I don't want this class to be too long and too complicated. Right, so they are our esters. Now there's plenty of practice questions for you to try in your notes. There's at least 6 A4 pages of practice questions. If you can get to the end of the 6 A4 pages, you're going to feel so much more comfortable when it comes to ester questions. And anything that was previously scary or a little bit complicated with esters is now going to feel a lot more comfortable. When you've finished the practice questions in the notes, now you are ready to try some of the ester questions that come up in the exam paper.